I'm delighted to present the Cambridge Computer Lab Ring Award for Publication of the Year 2020 to the team behind Sensor ID, Sensor Calibration Fingerprinting for smartphones.
Hi, I'm Alastair Beresford. I'm Professor of Computer Security at the University of Cambridge. And myself, Stan and Ian have been involved in this research project for several years.
So hi, I'm Ian Sheret. I guess it's difficult to say, but I'm mainly an independent consultant working in algorithm development, software development. But a little while ago, I did a really interesting postdoc at the Computer Lab in Cambridge. And in that work, that sort of spawned the idea for the work that's been done subsequently. It's been a long time in the making, but yeah, that's where it started.
Hi, I'm Stan. I'm a PhD student in the computer laboratory, and I'm currently at the end of my third year. And I work with Alastair, and then Alastair introduced me to Ian, who had initially had this wonderful idea about fingerprinting using the factory calibration, and we started collaborating from then. And yeah, it's been several years, but yeah, I think we made a good progress so far.
Well, congratulations all three of you on winning the Publication of the Year award for 2020. Could you tell us a bit about the work that led to the award?
So in this paper, we looked at the factory calibration behavior of the sensors in a smartphone. And because the manufacturing process is not perfect, the produced sensor typically suffer from various types of errors. And the factory calibration is a standard procedure to correct these errors. And what we have done is that we have proposed an approach to uncover these calibration parameters by simply studying the sensor outputs. And the sensors we have studied include the accelerometer, gyroscope, and the magnetometer. And we found that these calibration parameters are quite unique. And our study shows that for iOS devices, we can actually form a global unique fingerprint out of these calibration parameters. And we also found that it's very practical because it takes less than 1 second to generate and does not change over time. And it can also be used to track users across apps and websites. Because of the privacy implications, we reported the vulnerability to both Apple and Google, and they both fixed it recently.
Great. What do you think was the most exciting or important part of the work?
Just thinking about the origin of this work, I'd been working on completely unrelated work on mobile phone sensors, nothing to do with security or fingerprinting at all. I was interested in tracking the physical position of phones. And from that work, I'd known that some of the more expensive phones had a physical calibration. And that was just always, it was just a problem in my work because it was something I had to deal with when I was processing the data. It had never occurred to me that there might be something sort of useful or like interesting that could be done with that. But it just in working at the computer lab with Alastair pointed out some other work that people were doing on fingerprinting phones. And this work seemed to be generating a lot of interest. And that just seemed kind of like surprising to me. I was like, well, obviously the phones are uniquely identified. They're all calibrated and they've got this matrix on them. It's different every device. But it was clear to me that no one else in the field understood physically what was the origin of the uniqueness. And it was also just clear that nobody else really understood how to extract that data precisely. And so that was the start of this idea of like, it was just obvious that the methods that I knew about for extracting that information could be applied and be really relevant in the field of security and privacy. So that was the really exciting moment for me, is to realize something that I'd known for ages actually turned out to be really interesting to a whole bunch of people in a new field.
So I think another aspect that's interesting or exciting, well, certainly interesting to me, is that the methods that were being applied by the other researchers who were trying to uniquely fingerprint devices were take a bunch of data from the sensor, throw it into a machine learning algorithm, and then try and get it to somehow separate out the devices. But the machine learning algos weren't very good at this because, I think, as Ian was suggesting, the researchers who were trying to use that approach didn't understand or had no awareness of the fundamentals of what was going underneath the hood. And so we've ended up with an algorithm which doesn't involve really probably what you would argue is machine learning. It's quite a deterministic, well, that's not quite fair. Anyway, it takes a very different approach because we can build on the knowledge that Ian had in the analysis.
Like looking more generally, if you understand what's actually going on, you can make much more powerful algorithms in general than just the machine learning approach, where you generally try and avoid actually understanding physically what's going on and rather just leave that to the machine. So in cases where you can understand physically what's going on, it's a much more powerful approach.
Great. So how are you taking the research forward?
Have reached a natural point where, you know, we found the problem, we've come up with a number of fixes. Apple and Google have both deployed fixes, and at the moment I guess we can't think of good ways to break our own solution, so it feels like we're sort of done for now, although we have started looking at other kinds of sensor. So could you apply the similar kind of ideas to you know, cameras or other sensors that are broadly available on devices? It has to be said that the accelerometer, gyro, and magnetometer were a real sweet spot because they're accessible generally via the web as well as for apps on the device without any special permission. Whereas even cameras, for example, you often need permissions on the device and an app on the device to take pictures. I guess pictures are interesting because people just post them on the web. And so if you could say 2 photos are taken by the same camera, that would be kind of interesting. But at the moment, the ideas, at least that we've put in this paper, are not directly applicable to that kind of setting.
And what was the most challenging bit of the research work?
There was a lot of work involved, like just like it's okay to understand the basic principle. And I think even when I was in the department, which was like 4 or 5 years ago, the basic principle we understood. But there's so much more that you have to actually do in order to make a high quality piece of research. And Stan did almost all of that work. So, and that's stuff that I don't think I could have done, certainly on my own. You know, if it had just been left to me, this work no one would have ever known about it. It would have just been a conversation between me and Alastair in the office, which was interesting, but that's all it would ever have been. So it's really just all of the work that you need to do to prove that you have actually got a unique ID, like testing it on hundreds of different devices and showing that those devices are all generating unique IDs, and then doing a statistical analysis to show that that's not just a coincidence, that will go across the whole world. And then all the work that you need to do to collect data from these different devices in different ways, either on the web or from an app and all of that stuff. So the idea is like 1% of it, like 99% of it is just hard graft and overcoming like the individual challenges of the project.
Yeah, I think that on top of Ian's initial idea of how to recover the calibration fingerprint, I think the biggest challenge is just like what Ian said, is how to confirm our hypothesis with data to persuade others that this is actually the case, and especially persuade like Apple and Google to fix this vulnerability. And because we needed like abundant data for various user devices, we have to basically collect the data via the crowdsourcing platforms, such as Amazon Mechanic Turk and Prolific. And then analyzing those data also takes quite a while, and also especially try to estimate the entropy, because from an annual distribution, that is also quite a challenge. But I'm glad that in the end that we managed to make it work, and we estimate the fingerprint for the iPhone 6s has around 67 bits of entropy. That's why we think it's globally unique.